All right, so this is going to be the second part of my project deliverable. Here I'm going to talk about some of the code in a bit more detail, as well as some of my testing and how I essentially produced the results that I did in the first part. So to start off with, in regards to testing, you can see that my results came out well with trying to follow a pressure waveform and actually hitting that pressure waveform. But to test the controllers themselves, what I did was essentially write like a little bit of some unit testing just to make sure that the controllers were working well on their own. Here, if I just run this small program, so this is essentially testing out all the functionality of my system, and we get a essentially a pairing of desired states, current states, and the controller, in this case the PID, the output of that. And then in regards for testing for memory leaks, so with a embedded system, the memory is a little bit different, and actually in my case, really the only place where it made a lot of sense to use the new and delete was with the LQR controller. And so because it has this matrix of gains that are applied to the air, and it takes in essentially a fair amount more values than the PID does. So to test out or essentially verify that there were no memory leaks, I used Valgrind. And so now I can talk a little bit about the code that I wrote versus what was leveraged by the libraries. So this bioreactor firmware, this is all code that I wrote. So this includes essentially a data logger and so it includes the data logger and then the three control classes, one being a parent controller class, and then two child example controller classes, or inherited classes, I should say. And then the libraries that I used were the essentially a library for the servo, which is up here, and then a library for the sensors that were in my project. So I just made calls to those libraries, but the controller code is essentially the stuff that I wrote, as well as everything that's in this Arduino script that's flashed onto the Arduino. All of this is stuff that I've written, and I make calls to the libraries that I picked out for my advanced features. And so that sort of summarizes a bit of, I guess, the layout of what I did. But I can talk a little bit more about this script, perhaps, because this is what's essentially running on the Arduino in order to get the results that I did. Like I said in the video, like there's some essentially some global variables which are defined. This is again just sort of a quirk of the Arduino system, and it's kind of necessary to do this just given the way that the embedded architecture works. So I created essentially objects for the sensors as well as an object for my PID controller. And then there's this setup function, which this is essentially stuff that is going to run once when the Arduino is starting up, and before we get into like essentially the code that will loop infinitely on the Arduino while the system is powered up. So this is like stuff like setting the communication rate on the servo motor, as well as resetting our sensors, and also essentially defining what the gains of the PID controller were. So then we move into void loop, which this is where we basically have code that will just sort of run over and over and over again, and it defines how our system behaves. Everything falls into a state where either the system that I have is set to be on or off, and that is toggled via a physical button. So if this button is low or off, I basically reset some values that are important for when the system is on. And then I set the servo's position to be in kind of like a rest state, and that's indefinitely. So the servo essentially call takes the ID of the servo, it takes the position you want it to be at, and it takes the speed at which you want it to go to that position. So 1200 in this case was our rest position. So if that button is not off, then essentially our system is on, and essentially all of the rest of this code is running. So what I do here to kind of create, when the system's like fully on and running, I collected one waveform for the project, but how the system is really supposed to behave is we're prescribing a bunch of these waveforms cyclically. So I essentially define the function that I want the servo to follow, or the pressure. I essentially set the desired pressure curve. I won't go into much detail about how I came to this function, but it's basically just replicating the actual system we want, or the actual behavior we want. And then using my PID controller, I essentially send in the measured pressure and our desired pressure, as well as the essentially the delta time between each control call. And based on that, we essentially command the servo motor to move, and it basically moves until the servo reaches some limit that we've set of how far we want the paddle of that servo to move in. You can go back to the image real quick. So the servo motor basically moves until the paddle is distended, or not distended. It's extended further enough into the bladder that we want it to stop. And then at that point, it's basically going to retract, which is what happens in this block of code. And once it's done retracting, then we essentially go right back into our loop of pushing it forward. So that creates kind of this like cyclical motion that we want to follow. And basically, each time we loop over this script, no matter what we're doing, we're recording values that we can then see via a computer that's attached via USB. So that's essentially what's happening in this main embedded script. And of course, it's leveraging the code that I've written offline with my Bioreactor firmware library that I wrote for the Arduino. And then real quickly, can sort of, I didn't go over this in the, I didn't go over this in my video because I didn't want to take up too much time, but just sort of going back to my original class diagram, since the first deliverable, I added in this data logger because I realized it would be very important to kind of set that up so that we can record data in an easy fashion. But the structure of the controller has sort of stayed the same, where we have this parent controller and then child controllers. And you could have more of these, basically, just so long as you implement the abstracted methods that I have in my controller class. So that sort of sums everything up. Let me know if you have any further questions, but otherwise, thank you for listening. And I also just want to say that this class has been really fun for me as someone who is coming more from an engineering background, and I have had an interest in learning C++. And so I think that this, what we've learned in this class actually gives me a pretty big advantage, knowing some of the more proper techniques with C++ and how to leverage all of its capabilities. So thanks again, and stay well, and see you later.